All right, this video is for learning targets 1, 2, and 3. It's going to be a very fast video because I tried to record it during the live teaching in class and multiple attempts failed. So I'm teaching this kind of to just as kind of an overview. So it will be a little bit fast. You might need to pause it and rewind and whatnot. We'll talk about the targets in just a moment, but the warm-up is finding functional values, f of 0, f of 1, f of 2, for the function that's provided. I should backtrack just a little bit and notice and note that 3x squared, the fact that the variable now has a squared on it is what makes it a quadratic. This is the quadratic term. The minus 12x is the linear term, and the 6 is the constant term. But the fact that it has a x squared makes it a quadratic, and its picture in general is going to be a parabola. And the parabola looks like that. So what we did in the warm-up was we plugged in 0 for x, plugged in 1 for x, and 2 for x, and so forth, to explore what happens in this function when you plug these in. We'll ruin the surprise a little bit. When we plug these in, we're going to get the quadratic shape that we just looked at in general above. All right, so when you plug in a 0, you get 0 minus 0 plus 6. You get 6. So the ordered pair 0, 6 is a point that you could use to graph this quadratic. When you plug in 1, you get 3 minus 12 plus 6, you get negative 3. So 1, negative 3. When you plug in a 2, you get 4 times 3, 12, minus 24 plus 6, you get, negative 12 plus 6, you get negative 6. And this was by design. 2, negative 6 is the point right here on the bottom of the parabola, 2, negative 6, where it turns back around. That point's called the vertex. So what happens when you're plugging in numbers, which this is the only one I made them do by hand, the rest use the calculator to assist. When you plug in 3, you get 3 squared, 9 times 3, you get 27 minus 36 plus 6. 27 minus 36 is negative 9, plus 3, you get negative 3. The same thing you got when you plugged in 1. So the ordered pair 3, negative 3 can be used to graph this parabola. Notice it's the same y value on the left of the vertex as it is on the right. Let's do this next one then. 3 times 4 squared, 3 times 16 is 48, minus 48 plus 6 gives you 6. And once again, you get the same y value, 2 to the left of the vertex as you do 2 to the right of the vertex. What that's called is symmetry. Those are the same y values, those are the same y values, and 2, negative 6 is where it all turns around, the vertex. So anyways, we use this information in these 5 points to graph, we already talked about quadratic and parabola, to graph the function 3x squared minus 12x plus 6. So to recap, the vertex was 2, negative 6, and the points to the right of it were 3, negative 3, and 4, 6. So 2, negative 6, 1, 2, 3, 4, 5, 2, negative 6. Let me check that. For some reason, I'm feeling that. Yeah, 2, negative 6. 3, negative 3. And 4, 1, 2, 3, 4, 5, 6. So check that. Yeah, 3, negative 3, 4, 6, and 2, negative 6. All right. So because we noticed there was symmetry, we could go back and graph the points that are on the left side of the vertex, or we can use that fact that I'll draw a little dotted line to represent the symmetry. On the right side of the parabola, the points go up like this. They're going to do the same thing on the left side. That symmetry we were talking about on the warm-up, to the right of the vertex, the point was at negative 3, and to the left of it, one spot to the left, it was also at negative 3. That was the point 1, negative 3. 2 to the left of the vertex, it was at 6. or that was the 0.06 when we found that earlier, which makes the other half of the parabola, and it creates symmetry on both sides. They're symmetrical. You could fold it on that red line. Speaking of, that's the vocabulary word, axis of symmetry. It's a vertical line, so it has an equation. It's x equals 2. The vertex we've already talked about and identified. The vertex was 2, -6. The last vocabulary word that's in Learning Target 1 is identify the y-intercept. And the y-intercept is where it crosses the y-axis, not a new vocabulary word. The y-intercept in this problem was 0, 6. So that takes care of Learning Target 1. Making a table, check, we did that in the warm-up. And then identifying the vertex, the axis of symmetry, and the y-intercept. So that's Learning Target 1. For some reason it didn't get copied in these notes. It's on the plan sheet. We will also identify the y-intercept. Okay. Learning Target 2 talks about interpreting the vertex as maximum or minimum. And then Learning Target 3 is state the domain and range. Is directly related to the maximum or minimum value. So we'll take a look at that in just a minute. The next thing we looked at, we've already talked about that, was two very important key concept boxes and compared them to the problem that we just did. Y equals 3x squared minus 12x plus 6. In the general form, y equals ax squared plus bx plus c, if you can identify the a and the b and the c of the quadratic, you can find a lot of information about that quadratic, and it will be used a lot throughout this entire unit, not just this one target. So it's very important to memorize this information, put it on a note card, and practice using it. But for the problem that we have, that we used in our first example, the a, the b, and the c are as follows. A is the number in front of x squared, so it's 3 in this problem. The b is the number in front of x, so it's -12. And the c is the number without an x, it's the constant, and it's 6. The three things I'm asking you to do in Learning Target 1, y-intercept, axis of symmetry, and vertex, can be found by graphing and doing what we just did, or they can be found without graphing using these formulas. So to model that, let's start with the y-intercept. The y-intercept we just found was 0, 6. According to this table, the y-intercept is always, when you plug in a 0, it's always c. Well, if c is 6, then the y-intercept is 0, 6. Could have known that without graphing at all. The axis of symmetry, according to this, is an equation opposite of b over 2a. So the opposite of b over 2, the opposite of b is 12 over 2 times a, 2 times 3. 12 divided by 6 would have told us 2. X equals 2 is the axis of symmetry. If we look back at that, that's what we found. X equals 2 to be the line that would cut the parabola in half. All right, and then last but not least, the x-coordinate of the vertex is the same formula we just used, opposite of b over 2a. So the vertex would be 2 comma something. And to find that y value that goes with it, we would still have to find y equals 3 times 2x squared minus 12 times 2 plus 6. We'd still have to plug in 2 to figure out that y is -6. No shortcutting that. But anyways, that's one of the graphs. Now the second one we're going to end up using on the next problem. We'll continue looking at y equals 3x squared plus 12x minus 6. I'm sorry, I got that backwards. Minus 12x plus 6. Y equals 3x squared minus 12x plus 6. And start talking about Learning Target 2 and 3. If a is positive, which our a was positive 3, then our picture should be a U shape. And it will have a minimum at the vertex, 2, -6. The y-coordinate is that minimum value. So for our example, the minimum, the smallest that parabola ever gets is a y value -6. The smallest that function ever gets is -6. Okay? And then if a were negative, you'd have a upside down parabola, one that opens down, and you'd have a highest point or a maximum. Again, though, the maximum would be the y-coordinate of the vertex. Okay? We'll finish domain and range on the next problem. I think that's a lot of information to absorb already. Let's just kind of start over and use some of the things we just learned. Graphing, find the y-intercept, axis of symmetry, and it says the x-coordinate of the vertex, but we're going to go ahead and find the whole thing, but at least the x-coordinate of the vertex. And we're going to involve the calculator for this one. The y-intercept, looking back to, this is page, by the way, I should note that, this is page 250 in your green book, and this is page 252 in your green book. On page 250, the y-intercept is c. So we'll apply that in this new problem. A is 1, B is 4, C is -3. The number in front of x squared is always 1 if there's not a number written there. So the y-intercept is c, it's -3, the point 0, -3. The axis of symmetry, I'm quoting, you could back the video up, but the formula says opposite of b over 2a. So that would be x equals the opposite of 4, -4, over 2 times 1, -2. So x equals -2 is the axis of symmetry. The x-coordinate of the vertex is the same formula, opposite of b over 2a, so -2 comma something. Now let's go ahead and find f of -2 by squaring -2, adding 4 times -2 minus 3. So we get 4 minus 8 minus 3, so -7. The vertex in its entirety is -2, -7. The axis of symmetry is x equals -2, and the y-intercept was 0, -3. All right, now we'll bring in technology to help us out. These buttons, if you need to review what buttons I'm pushing, I'll have to do that with you in class, but we would graph x squared plus 4x minus 3 to take a look at the picture, and then go to the table to pull out any points that we would need to graph it on our paper. We already knew from above that the vertex happened at, whoops, I think I typed something in wrong. No? That the vertex happened at -2, -7. There we go. Got to get my head straight here. So I'll put -2, -7 in the middle of this graph, and I'll see -6 below it, -6 above it. I see -3 below that, -3 above the -6. I'm seeing the symmetry that I'm supposed to see around the point -2, -7. So I'm seeing the vertex is -7. When you plug in -2, you get -7. So we'll plug in a few points around that and just pull them off the table. At -4, it was -3. At 3, it was -6. At -1, it was -6. And at 0, it was -3. So we'll use those points to graph the parabola. Those ordered pairs, use those ordered pairs to graph. Start with the vertex because everything revolves around the vertex. -2 down 1, 2, 3, 4, 5, 6, 7. To the right of that, it's at -6. To the right of that, it's at -3. Looks like we could probably fit some more points on this graph, so I'm going to go ahead and look back at the table. And the next point is 1, 2. After that, the point to the right of 0, -3 is 1, 2. So we can graph that one, it'll fit. And 2, 9 we could also graph. So I'm going to go ahead and graph those, 1, 2, and 2, 9. And that's half the parabola. To the left side of the parabola, to the left side of the vertex, you would have another point at -6, at -3, +2, and +9. That's letting the symmetry help us graph this a little faster. So connect those using a smooth curve to create that parabolic shape, the parabola, and check, we've got it graphed. The vertex is included on the table right here and on the graph right there. All right, the last question, maximum or minimum, what's that value, domain and range, all revolves around page 252. So again, if U-shape, it's a minimum. Oops. If it's a U-shape, it is a minimum, and the y-coordinate is that minimum value, the of the vertex. That here, this has it's a U-shape, so it has a minimum value, and that minimum is the y-coordinate of the vertex, so that would be -7. Domain and range. I'm going to skip to range because we just said the minimum is -7, and that's in our head. Range is talking about what y values do you get out of that function, what are the y values, and if you just said the minimum is -7, you were saying the smallest y is -7. And if the smallest y is -7, then your y's start at -7 and go up. So one way you could write that is y is greater than or equal to -7. That's your range. The x is talking about, the domain is talking about your x values. What numbers are you allowed to plug in for y equals x squared plus 4x minus 3? There's no number that you couldn't square and then add 4 times that number, so the domain is going to be all real numbers. And I know that most people start to memorize that pretty quickly. Domain is always all quadratics, and that's fine, but I don't want to just leave it at it's always all real numbers. So I want to take a look at a couple of functions here where the domain, the thing that you are allowed to plug in for x, not all real numbers. First, in a fraction, x is in the bottom of a fraction, you can't put a 0 in for x. So the domain for this problem would be all real numbers, but x cannot equal 0. For the example, y equals the square root of x, for x, we can put in any number, but you can't put negatives in. You won't get a real answer. So your domain would be greater than or equal to 0, anything but negatives. All right, so anyways, we're not talking about those in this unit, but I just wanted to mention the domain is not always all real numbers. However, it is for quadratics because there's no restriction to plug in for x. So that concludes the notes for Learning Target 1, 2, and 3. If you need more help with it, and you probably do because this is a lot of information, just come in and we'll work on it together. All right.